This
of
conference will now be
SDLC
recorded.
is that we have to deliver the application or product to the customer, okay, in a timely and prompt manner. This is what SDLC is all about. This is what DevOps is all about. So SDLC, you can say it is nothing but a part of DevOps. DevOps is a practice, it is a standard, it is a culture which is followed by every IT industry in order to fasten and automate the process of the delivery of any application or any product. Okay, so when we talk about SDLC or when we talk about the DevOps, one thing is the prime thing, and that is the customer and the client, and the application and the delivery to be reached to the customer. So, second thing in this DevOps or SDLC is that we are going to understand is what is the first phase in this. First phase is the planning. So let me take an example. For example, we have to make an application or we have to create a product. Say we have to create Amazon Fresh. So this is an application for the delivery, for the delivery of goods or the delivery of, you can say, daily products. Okay. So first thing we need to understand when we are going to build an application, what the customer requires from that application, what the client needs from that application, what are the end goals of a customer. So end goals of the customer are that, say I need the delivery in just 10 minutes, I need the delivery in just 5 to 10 minutes, okay, or I want to do the cashless payment. All these are end goals or all these are prerequisites or the requirements of the customer, you can say. Okay, so whenever a product or application is made, the customer or the client has some requirements. They give some requirements to the business. Okay, so first thing which I have written in our slide is the planning phase. Okay, or you can say the requirement analysis or the planning phase. These two things are the same. The first circle which you are seeing in the SDLC. So, what who is doing the planning now? So, in a company, there is a hierarchy. Okay, so the person who is involved in planning or who is involved in taking the feedback or requirements from the customer is nothing but the BA. Okay, the business analyst is the person who will take the requirements from the customer, from the client, and will draft it in the form of a documentation. Okay, that documentation, we call that documentation as nothing but BRD, business requirement documentation. Okay, so this is the first step, that a business analyst has to create a document and it will take all the requirements, prerequisites from the client or the customer, and he or she will draft it in the form of a documentation draft, which we called as requirement documentation or BRD. The second thing which is involved in the process is The second thing which is involved is defining and the designing phase. Now, these requirements, the BA, they will hand over it to the program owner or the product owner or the program manager. So they will see what things we can achieve from this BRD documents, what are the priorities and goals which we can charter out from this BRD. So the the next step which we can say, the next step will be, so this PO, product owner or program manager, what they will do, they will prioritize these goals from BRD. So everything can't be achievable, right? So they will say that, okay, the customer requirement, which is saying that we can create the app that will deliver the grocery in 10 minutes. Okay, that is achievable. Let us take that. Okay, so the program manager or the product owner, they will prioritize those things from the BRD, and they will make some actionable goals, or they will create some actionable items. Okay, so next thing, after designing and defining the goals and items, the next thing will be implementation phase. Now this program manager, or we can say the product owner, does also one thing. They take this particular goal, they will call it as a feature or an epic. Okay, so usually in IT or in the software, we use different program management tools. So one of the major or main program management tool that we use is Ado, or we use Zira. So what this program manager does is, they will take these actionable items, they will convert them into features, and out of those features they will make certain stories or epics. So what they do is, they will convert these actionable items to Zira epics, or you can say features or stories. Next, what should happen is that these Zira epics or features are taken by the developers. Now developers will create. Okay, now developers will create the application with the help of the programming language in which they are comfortable. But before that, the solution architect comes into picture. So what does the solution architect does is, he or she gives the high level and the low level design of the product. So next is the solution architect. He will give a low level design or high level design of this application. So what does this mean? High level definition means he will create what should be the modules, what should be the infrastructure, what should be the high end picture of this application, and what is the low level design is, what will be the programming language which will be used in this, how we are going to create the small functionalities. Everything will come into low level design. Okay, so next thing is, after the solution architects decides this and does the high level design of these epics or stories, the developer starts now to take, the developer will take these epics from the Zira and start working on the stories in their favorite programming language. Okay, once the developer creates the chunk of the code, then it goes to the QA team for the testing. The QA team or the testing team will test the piece of code. They will do the unit testing, they will do the functional testing, they will do the automation testing, and see that the code is intact or not, in all the ways. Okay, now there is one role also that comes into, which we called as the DBA. Okay, so database administrator will create the database and administer it. So these things are managed. You can see the entire software development cycle is managed from BA to product owner to to program manager to solution architect to developer to QA to DBA. Now, where comes the AWS cloud engineer, or where comes the DevOps engineer, or where comes the SRE? Let's go to the slide again. So first I will come back to this SDLC picture. So I think the first part is the requirement analysis, which is the planning phase done by BA. The design phase is the defining and designing phase, which is done by the program manager, or you can say the solution architect, okay, in defining the high level design and the low level design. Then the development phase done by the developers, the testing phase done by the QA engineers. Now this evolution or the deployment phase, here comes the picture for the DevOps engineer. Okay, so if we see this roles and responsibilities picture, after these QA engineers, there comes the AWS DevOps engineers. Okay, but now why the AWS and DevOps engineers both are coming into picture altogether? Because most of the applications have been migrated to the cloud infrastructure. Before, when there was a picture of on-prem premises, when there were huge servers landing into at one place or in one premises, then the things were entirely different. But when all the applications, all the services have been migrated into cloud, now the AWS services as well as the DevOps engineers have come into existence, so that they can leverage the use of the AWS services, and they can also automate the deployment or the delivery of the application in a faster manner. Before that, there was no automation in delivering the product to the customer. In the deployment phase, if you see, or the evolution phase, if you see, everything was sort of manual. Okay, but now when the DevOps has come into picture, when this practice or culture has been taken up by the software industry, now everything, this whole implementation plus testing plus evolution stage has been fully automated. So after this AWS DevOps engineer, once the application is fully live, it is fully deployed on the production server, then comes the role of site reliability engineer to see the reliability of this product or the application that has been launched. So we have to make sure, we have to understand that AWS services is the gist or the plinth of the, or the foundation of the DevOps. SRE, for SRE, the DevOps and AWS is the foundation. One cannot make, or one can't be a site reliability engineer without understanding the AWS and the DevOps. That is very clear. And once we are doing this certification, or once we are doing this course, you will be very, that what are the AWS services we are going to use, how we are going to migrate the services, okay, how we are going to migrate our application from on-prem to the cloud, and how we are going to automate everything, whether it is the creation of resources or any other thing, and how we can do all the pipelining from this deployment phase to the from the development phase to the deployment phase altogether. Now let's understand what is cloud computing. So if I come to this picture, you can see I have clearly written on-prem architecture. So I will say, before, when cloud computing was not into existence, okay, you can also think that you have to start a business, you have to start a small startup also. So what and all things you will need? You will need servers, okay, you will need databases and storages, you will need different network equipments, whether it is routers, switches, LAN cables, everything. And when you are putting these big servers in a place, you will also need a big space, a big property to install them. It's not like that you can install servers in just one small room. Okay, so you need a space also, you need property also. And even if you are planting or deploying your servers in a small room, that is also taking some space, that is also means I mean you have to take some place on rent on which you can put your servers on. And then if you're using these servers, you have to put air conditioners, you have to use electricity power to run these servers, to run the network equipments, and the other things, right? And then you need some technical experts also. Suppose there is a technical fault in one of the servers, there is some misconfiguration into the servers or into the databases, then you have to employ some technical experts also in order to debug that. And also you need some security personnels also to take care of this on-prem configuration or of this on-prem architecture, right? So what is the solution? So let me make you understand this way. So what I am going to tell is what was the disadvantage of then on-prem architecture. So what do you think from this diagram? I think you can very well understand that this on-prem architecture will consume a lot of money and resources in the form of servers, in the form of databases, in the form of networking equipments, in the form of security personals, in the form of I mean in the form of uh, all the electricity or power, in the form of everything, I mean. So what was the solution to this issue? The solution of this issue is to we can we can actually make use of virtual machines, or virtual servers. And this can be achieved by the process which is called as virtualization. So now what is virtualization? Virtualization, in order to understand that, first you have to understand that these cloud providers, whether it is AWS, Azure or GCP, they actually come up with an idea is that okay, we have the servers deployed in our region, we have the servers deployed in our area, we will take care of the databases, we will take care of its configuration or misconfiguration, we will take care of the network equipments, we will take care of the technical experts and the security, we will take care of the electricity and the power, we will take care of the heat generated by the servers, we will take care of the air conditioners, we will take care of everything. You only use and pay for the amount of time and the amount of the configuration or the type of the configuration you are using. Okay, so there comes the concept of cloud computing. So from on-prem to pay as you use concept is nothing but the cloud solution, the cloud computing solution. Now, why computing is added into the picture? Cloud is fine. We got to understand that okay, I don't need everything in one place. I can't invest a lot of money uh, and resources on all this infrastructure. But then how can this computing will come into picture? What actually it is computing? So from there comes the concept of the EC2. So I want to make you understand before going to the server or EC2 launching, or before going to make you understand how to connect to it. Let's understand first that what is virtualization. So you take this case in which this is one picture in which you are seeing that there is a HDD of 200 GB. We are using a RAM of 50 GB. we are having some operating system on it, and say that operating system is a Windows operating system, and we are going to launch a Windows application on it, and that Windows application may take 5 GB RAM and say 50 GB HDD. Okay, so what are you seeing from this picture? What is the problem in this picture? So if we see it clearly, we can see some potential disadvantages. First thing is, if my operating system is Windows, I can only install Windows app on it. The second thing, if the total HDD of the hardware is 200 GB, it can happen that for my application, okay, I can only use 5 GB. If my RAM is 50 GB, I am using only 50 GB, 5 GB RAM and 50 GB HDD. So we can understand there is a wastage of the memory of the storage here very clearly, and it is also dependent on the OS. If my operating system is Windows or Linux, I can install only that particular application on it. So what is the solution for this? The solution for this is to use the hypervisors or do the virtualization. So what does the hypervisor or virtualization concept means? We will take the same case, HDD of 200 GB and RAM of 50 GB. Okay, we will use a logical scissor. You can consider it as a logical division. Okay, we are dividing this hardware into different machines. Okay, so one machine will be using RAM of say 10 GB and HDD of 50 GB. The another will be using a RAM of 10 GB and HDD 50 GB. The third machine will be using a RAM of 30 GB and HDD say 100 GB. So on the first machine, you can see we can install the Windows OS. On the second machine, we can install the Mac OS. On the third machine, we can install the Linux OS. So our one problem is solved, that the operating system was dependent, or you can say the application was dependent on the operating system. Now with this logical scissor, we can uh, install any operating system on the machine. We can install Windows, we can install Mac, we can install Unix or any other. And the second problem was the wastage of the storage or the memory. So here you can see 5 GB RAM was only used, where the total RAM was 50 GB. So 45 GB RAM was wasted. Here HDD was 200 GB, where only 50 GB HDD was used. So 150 GB was wasted in the former case. Here we can see that we have divided the hardware configuration in such a way that we can use different operating system, we can use variable HDD and RAM, and can launch our machines. These machines are nothing but is called as virtual machines. So virtualization will give you nothing but the concept of virtual machines, which we are going to use in the cloud architecture, which we are going to use in the cloud. Okay, so let's understand now in a better way. So what this virtualization has basically done, it has basically acted as a logical scissor, and it has given the creation to virtual machines, and if we are gonna use these virtual machines or access these virtual machines using the internet, it is nothing but the cloud computing. So, on the on-premises setup, it may happen that these virtual machines will be landed somewhere, will be landed at some place. Okay, we can install a Zen hypervisor. It is like a software. Okay, and it can logically scissorize or divide or partition your HDD and RAM into different machines. So if this is the issue, then we can say that okay, we have a localized on-prem machine or a server, big server. We have installed a Zen hypervisor or a Zen hypervisor software on it. It is logically divided the entire hardware into different virtual machines. Then what? Is it cloud? No. Why? Because again, it is landing somewhere. It is taking some space. It is taking the same cost. It is taking the same resources. Then what? Then what have you? In what way have you reduced the cost? In what way you can say that we? It is like a rent on service or pay as you use service or pay as you rent service. So when virtualization is added with cloud, only then with internet, okay, then only we can say that it is a cloud computing. So now if I can access this virtual server from sitting anywhere around the world, if I can access this virtual server from sitting anywhere across the world, if I can access this virtual machine sitting anywhere across the world, then I can say that I am accessing the cloud computing architecture, or I am accessing the resources, or I am accessing the virtual machines on the cloud. So one or two terminologies will be should be very clear to you before I proceed to anything else. So what are servers? First thing, in every class of cloud, we are gonna talk about the servers. So every time we hear this terminology, but we don't understand what it exactly means. So servers are basically the hardware. Okay, when I talk about hardware, what is hardware? Means CPU, RAM, and your input output. So your laptop is also a server, your desktop is also a server, but it is a server of less configuration. Say when we launch an compute, or when we launch an instance into our AWS cloud, sometimes what happens is we launch an instance of one CPU. Then also it is server. 50 CPUs, then it's also a server. So server, if a basic definition of server is, it is certain hardware, it has certain CPU, it has certain GB of RAM, it has input output. Okay. What is an operating system? This is the second terminology, because when we are going to launch an EC2 instance, or when we are going to understand the virtual machines in a deeper manner, we should know this. So what is an operating system? For example, you are going to buy a laptop. Okay, you have bought it. So the laptop manufacturer will already install an OS on it. So you consider you have taken a hardware, you have taken a server, but there is no OS installed on it. Are you able to install any application on it? For example, you want to install Google Chrome. Google Chrome is a basic browser, okay, internet browser, which you want to install. Okay, so suppose you want to install Google Chrome on your laptop. Suppose there is no OS. Will you be able to install? No, the answer is no, you can't. So what is the operating system? It is a middleman. It is an intermediate person, okay, between your hardware and the application, which will help to uh, join the both. I mean, the user is me or the user is you, okay, and you want to install Google Chrome, that is the application on the machine. So the middleman which helps to install that application on the hardware is nothing but the operating system. Without operating system we can't install any application on any hardware. Next thing is virtual machine. All these terminologies will be very much clear to you. So virtual machine is when we are doing this virtualization, so using the same hardware resources, that is your HDD and RAM, you are generating n number of other machines or other servers or machines with a varied RAM and HDD. So in the example, you have very clearly seen that we have a machine with huge GBs of HDD, huge GBs of RAM, and we are able to create 3 VMs out of it. You can create n number of VMs depending upon your requirement. So why I am calling it a virtual machine? Because it is not the actual hardware, it is a derivable, it is derived from a main or the base hardware, which is having a configuration of 200 GB and say RAM of 50 GB. Okay, so this concept of virtual machines and the normal server, this difference should be clear to you. A normal server or hardware which is virtualized, in which no virtualization has been done, no hypervisors has been used, we call it a simple server. If we are using a logical scissoring on it, we are generating the virtual machines. And when we are accessing these virtual machines over the internet, we are calling it as a cloud. And we are paying as we use, we are calling it as a cloud computing. So you should know the very basic difference between the on-prem architecture and the cloud. Why on-prem architecture has some disadvantages or the drawbacks. Why why we moved to the cloud computing. What was the foundation of the cloud computing? What is virtualization? What is a virtual machine in real terms? How it differs from a server? Okay. Why is the operating system necessary? These are the points. It should be very clear into your mind. The next point which we are gonna cover is, as I told you, even after creating the virtual machines, the localization was an issue. When we used to access it over the internet, we use it cloud. There are different type of, before everything was bare metal. Now Zen hypervisors are being used. Before coming to cloud deployment models or types of cloud and the course overview, I want to give you a, okay, so we have, I think I have, okay, so this is some point. Okay, why we are using the Linux distribution here? Why I'm going to use the Linux? Why not Windows or why not some other OS? So you have to understand that there are some advantages of Linux which the other operating systems don't render. So Linux was actually the pre-derivative of a Unix operating system. Okay, so it is basically an freeware or openware. The first thing, anyone can contribute in its development, and it has no licensing. That's what we mean usually by a freeware or open source or openware. So if we take any other operating system case, say Windows or Mac OS, it has a certain licensing, okay, and we have to adhere to that. But the Linux is freeware, and it is an open source software. Many developers have contributed in its development. And second thing is the Linux is highly reliable. So if you see, if we take the example of Windows or any other operating system, we have to install an antivirus for that. We have to protect it from malwares. We have to protect it from other security threats and attacks. In Linux, there is no use or no functioning of using these anti-malwares or anti-security threats. Okay, so it is highly reliable, it's highly secure, you can say. Okay, the third point is, apart from being open source, highly reliable, it is not so bulky. Because what is the reason that it is not so bulky is it is not using any UI. So if we talk about the case of Windows or Mac OS, basically it has a certain UI. Okay, you can see, if you want to go to, say, open a folder, open a file, you click on that folder and file and you go to that place. But in Linux it's not like that. Say I have to create a directory, I can't go to the UI and just click on the folder and the folder will get opened. Okay, it is not the case in the case of Linux. So it works primarily on the basis of what you say CLI commands, or it mostly uses the scripting language in order to even create the directories and files. You know, we are in this course going to take up the Linux command or the shell scripting, because even as I told, in order to make a directory also, you can't go and click on the folder and open that folder as we do in Windows or Mac OS. We have to use a command, say mkdir, that is for making the directory, or in order to creating a file, say we use nano command, we use vim command, okay, to create a file. Okay, these are all file editors in Linux that we will learn in this course. There is mkdir to create the directory. Okay, so, or folder, anything you can say. So this is the another advantage. It is not so bulky, so it is not using any UI. It is all based on the scripting language. It is all based on the CLI commands. So these are few of the reasons that Linux is preferred over the you can say Windows or any other OS. The next thing which we are going to take up is the Linux distribution. So Linux comes in various forms and flavors. So the different distributions which we can use in Linux is Ubuntu, Red Hat, Debian, CentOS, etc. So these are just different distributions of Linux that one should know. Usually, when we are going to create a instance, I mean in it on AWS cloud, we usually go for Ubuntu or Red Hat, but we can use any other distribution as well. So these are the primary points I want to take over. Let's go and understand. Suppose this problem has happened, we are going for an on-prem architecture there, so we have to think about all these things: servers, air conditioners, big space, databases, networking equipments, technical experts, security, land, everything. So I need a server right away. So what should I do? So for that, please go to your AWS management console. So simply what you have to do right here, AWS Management Console login. Open the first link. You can see a page like this. Okay, so like you guys don't have an account. So if you don't have, please click on this create account. Since I have, so it will directly land me up to the page. So what you guys can do is, you can click on create account. I have added some pointers here so you can follow this. what happens, you have to go to AWS console, management console page. There you have to click on create an AWS account. It will prompt you for an email address and a password. So I request you guys not to use your office password, because that will make it like an business AWS account, and will cause some issues later on. So better is you use your personal email ID, or you can create a different Gmail ID for this, and you can choose a password. Okay, any strong password you can use. Then once you enter your personal email ID and your password, then your the email ID which you have given, it will the code will come in it for the verification. That most of the time we have seen that it comes, right? You have to click and verify your mail ID by going or checking into your inbox. Further, you have to give your contact information, your country. Say you are from India, you have to give that code +91, your number, your phone number. Now, don't be frightened away by these payment details and everything. Okay, okay. Before this payment details, once you put your phone number, it will ask for the PIN. So on your number, the PIN code will come, some 6 digit. You have to put that, and your number will also be authenticated as your email address. Now it will ask you for the payment details. So for the support plan, you have to go for the free tier. So there are different plans, so you have to go for the free tier account, and there you have to put your credit card. Okay, so you have to put your credit card details, so it will just deduct 1 rupees or something, a very less amount, just to authenticate that it is a authorized user or not. And there will be no payments post that. Just for the authentication purpose, it deducts 1 rupee or so. Okay, so you have to just do this process, and your AWS account will be properly created. I don't think it is a tough process. You please try once. In our next class, I will, otherwise, because my account is already there, so I can tell someone from you only to share your screen. I will show you the process. But let's come to launching an instance. So what I did is, okay, let me go. There is a service called as EC2. So I told you I have a problem that I don't want to go for on-prem. I want a quick server right away. I want a quick virtual machine right away. I need a virtual server right away. So what should I do? Is there any service on the cloud, on the AWS cloud, that I should go and I should create the virtual servers in the cloud? Because I can't invest so much money on buying the land and then installing the servers and everything, which I've shown you already in the diagram and explained it. So the service which AWS is providing us to launch an instance, you don't confuse me saying launch an instance. It is basically launching or creating a virtual server or a virtual machine in the cloud. Okay, so just let me write it so that if you're not aware, EC2 is a service. Okay, it is a resource, you can say, on the AWS cloud. It is a service on AWS cloud, in which you can create virtual servers or machines on the cloud. Okay, and what does this EC2 means? It means elastic compute cloud. Why it is called as elastic compute cloud? Elastic because it is scalable. What is the property of elasticity? You can stretch it as much as you can. Suppose you have an elastic band, you can pull it from both the ends and you can increase the size, right? So if you have a virtual server on the cloud, today you can create one vCPU, or once you can create a virtual server having a single CPU, right? And tomorrow You can create a CPU which is having 50 CPUs. Okay, the only difference is the cost will vary. When you are using one CPU, the cost will be entirely different. When you are using 50 CPUs, you are renting it from AWS, the cost will be totally different. You take the example, when you are taking a 1 BHK, the cost, the rent will be totally different. When you are taking a 3 BHK in any city, the rent will be totally different. So depending on your configuration that you are using, the rents or the cost of usage will be charged by AWS. It will vary, right? So elastic meaning, I think that is clear to you. Compute is, you can do the computational things. When we create any virtual machine, or when we create any virtual server, what is our intention is, we want to deploy applications on it, we want to run different applications on it, right? We want to see the working of any application. Okay, we want to test any application. That is what computation means. And it is also called compute because sometimes this EC2, this EC2 has a very big family, right? It is not only T family, it has also M family, X family, that is used for higher computational purposes also. It is not just for the just for installing or deploying the application. It can be used for on a bigger picture also. And then cloud is, you are creating your virtual server on the AWS cloud itself. Okay, so that's how the name is. So let me go back to the console. Okay, let me tell you what this entire black screen or this means. This is AWS dashboard. We can also call it as AWS UI. Okay, so we can create the resources from the AWS dashboard, which we are gonna learn in this curriculum. And we are going to create the resources. Okay, this instance which I am talking, which I am gonna talk about it now, we can create it through the code also, which we called as IEC, which uses the feature of API calls that we are gonna take in the further curriculum, in the same curriculum. But first we want to understand how to create a resource, okay, from the AWS dashboard or the UI itself. So I think this is clear to you. So this creates, as the name suggests, creates, manages and monitors virtual servers in the cloud. Why monitoring is also there? Because later you will understand that with every service AWS has, it has attached a monitoring service which we call as CloudWatch. Okay, attached to every service. What is CloudWatch? CloudWatch is basically an AWS service, which is a monitoring service. But by default, this CloudWatch service is embedded in every AWS service. That's why on the dashboard you can see monitor virtual servers in the cloud. Manage, create also, let's go on. Let's go further. So you can see here on the left panel instances. You can see here also launch instance in this yellow bar. So you can click anywhere here or there. Okay, you will land up to this page. What is an instance? EC2 is a service. Instance is a resource. I will again repeat, you should know the difference. EC2 is an AWS service, okay, responsible for creating virtual servers in the cloud. Instance is your virtual machine, is your virtual server. How can I say this? Let me take the example. Ram, car vendor, is some car vendor who sells cars. The particular car you want to buy is your virtual machine. So you can compare the terminologies in so that you don't get confused about what is an EC2 and what is an instance. EC2 is an AWS service that is given by AWS to us to create, manage, and monitor the instances or the virtual servers. Instance, whenever you hear the word instance, you should think always about virtual machine or virtual server that we have understood till now. Okay, so you should not be confused with between EC2 and instance. Now every time I will use a line launch an instance. What means launch an instance? Launching an instance means I'm going to create my virtual machine. Let's go back again to the dashboard, click on the launch instance. Now it is asking me, so this is actually a very quick demo for you guys. It doesn't mean that I'm not going to repeat it again. I want to show you the beauty of the cloud computing via this example. So don't get confused or frightened away that, oh, what is this, why the speed so fast and everything. You should not be confused at all, because I am going to take the first service as EC2, and I'm going to tell you at least 5 ways to create an EC2 instance and how to connect it through via SSH clients, through your command prompt, and via through your Git bash also. So you should not be frightened at all that what is going on in the class. You should only understand one thing, that through an AWS service which is called an EC2, uh, ma'am is going to launch an instance. I am getting a server, or you guys think that you are getting a virtual server, and I have to connect to that server. That's it. So let me give the name XYZ anything, say my web or my server. I will name it any name you can give. So as I told you that we can use any distribution. Okay, so you can see here Amazon Linux. It is a proprietary service of AWS. Okay, for the OS it provides. Then Mac OS we have, because Mac also has a WSL installed, Windows also have a WSL installed. So you can use any of these distributions apart from Mac OS and Windows to launch your virtual server. Let's go today with Ubuntu. So I'm clicking on this Ubuntu. So this AMI, Amazon Machine Image, we will understand it in the class, it in more detail. But you can just understand here that we are using a Ubuntu, which is AMD 64 processor. And if I go down, let me take the instance type as T2 micro. So basically there are many families available. What is an instance type means what is the configuration of the hardware you are going to use. Okay, you have selected the OS operating system as the Ubuntu, but what about the configuration of the hardware that you are using? What is the configuration of your virtual machine? Like in the example, we have talked about the configuration. This is nothing but the configuration. How many CPUs are you using? What is the RAM? What is the HDD? Okay. So this is nothing but the instance type. So here also you can see that the free tier eligible instance types are very less. Only two are there if you see and go down. So others are being chargeable since we are using a free tier account. So let me go with the T2 dot micro family. You can see here it consumes one vCPU, virtual CPU, and one GIB. Okay, GIB is something 1.07 GB. It is not exactly equal to 1 GB. Now, not to get confused, you can just understand that we are using a hardware configuration which is having one CPU, very single CPU unit, and 1 GB memory. That's it. Don't go into much detail. When we take the EC2, we will go deeper. Okay. Next is key pair. Key pair is whenever you take a laptop, anyone can't access assess it, right? We create a username, we create a pin, okay, and then we can assess into it. So key pair is similarly like that. So say I am keeping the name as August key or something you can keep. So there are two private keys authentication type. We usually go with RSA. Okay, RSA is a type of encryption. ED 25519 is also type of encryption, but usually here we go for RSA. Now you can understand or talk about these .pem and .ppk formats. These are very interesting. Both the private key formats are used for SSH. Okay, secure shell. Okay, for logging into. Okay, first you should understand what is SSH also. So see, SSH is a protocol. Secure shell, we called it secure shell. Okay, it is a protocol. SSH is a secure shell protocol that we use to access a remote machine. For example, I am in India, my machine is somewhere else in some other part of the world, but we are seeing in the cloud. This virtual machine might be in some part of the world, right? So I am going to access this machine. How I am going to access this machine? Via this SSH protocol. So we will talk about again in detail. So you just understand one thing. For right now, I want to generate a private key. I'm going to use a .pem. You can use .ppk if you have a putty SSH client. We are going to understand what is a MOBAX SSH client, what is a putty SSH client. But right now, go for .pem. It is a text file format. Okay, and .ppk is a binary type format. So let's go for .pem and create the key pair. So what happens is this key pair will get downloaded into my downloads folder. Okay, so if you open this file, I am opening it via notepad, you can see that it is like a text document. Okay, it is a RSA encryption file. It is all the type of encryption which has been done on this file. So one public key will go to the instance, to the virtual. I am going to access the machine remotely. Now you can see also this. I am going to take my region as North Virginia. You can see there are so many regions here. What does that mean? Okay, you can create your virtual machine in any of the regions. Even India is also there, right? You can create, so there are two main regions which are being used. So Mumbai and Hyderabad is there. So you can use any of the region and you can install or create your virtual machine. Okay, so let's not think much about the network settings now. So it is the, you can understand that this is the public network now we are using because we want to SSH to that, or we want to assess that virtual machine, right? So I am just keeping it as it is. Only you have to tick mark this. Okay, allow SSH from anywhere from the internet. This is the main thing because we are gonna remotely assess this machine. Okay, so storage I am giving just as 8. You can give 10, 15, anything. Again I say the storage, the how much you increase the storage, you have to pay for that. So let's keep it basic as 8 gp3. There are other storages also. We can see root volume storages are gp3, gp2, io1, io2. We will take this up when we go to EBS, EFS and all the storages. Okay, storage services. So let's launch an instance. I'm not going to advanced and details now because we are not launching a web server. Okay, so you have to just go to these instances. So see, you can see there my server is the name of the virtual machine which is created on cloud. This is the instance ID. You can understand like it is like a tag that AWS should understand. Okay, they have created this server, let's put a tag on it. Okay, Then instance type, I told you T2 micro, we are consuming one virtual CPU and 1 GB of memory. Status check is going on. Let's not talk about alarms. If we go to the CloudWatch, we can see this. It has taken the availability zone as US East 1. Again, in our course, we have to understand from the basic what is a region, what is a AZ, that is an availability zone. Now, the thing is, which you should appreciate now is, it has got a public IPv4 address and a private IPv4 address. So, suppose this is my laptop, right? Let me open the command prompt simply. This is my command prompt open. Okay. I am using IP config command. So if I'm using ipconfig command, there is some configuration of my PC which is coming out. So you can see that it has a IPv4 address of 192.168.1.36. So this is the private IP which is given to me by the NIC or by the laptop provider, right? It is on the NIC card of my laptop. So like this, like my laptop machine which has a private IPv4 address, this machine which we have virtually created, it should also have a private IPv4 address. So this machine which we have, the instance which we have launched named as my server, has this private IPv4 address. Now you will ask, what is the public IPv4 address of your laptop? What's my IP address? So you can open this link. What's my IP address? Okay, you got the public IPv4 address also. This is given by the service provider. I mean, suppose I am using Act Fiber of Airtel. So those from where I am taking the internet, those guys have given me this public IPv4 address. So this is the public IPv4 address of my laptop, and using the IP config, I told you that is the private IPv4 address of my laptop. Similarly, this virtual machine also has the same. Now let me copy this. So there is this blue button. Okay, you can copy this. So you can see public IPv4 address is copied. Okay, you can go again to your command prompt. Don't get confused if I am a little fast, or if you can't understand, because I want to just show you the beauty of accessing the virtual machine from a cloud through your personal computer, through your laptop. Okay, so I'm using SSH command, SSH minus I, my key pair name, I have put some August. Okay, so one thing, the key was downloaded to my downloads folder. Let me go to downloads. Then I should use this command, ssh minus I August. Our OS was Ubuntu. And let me paste this public IP, which was this 54.85.82.91. Okay. Let me hit enter. Let me write yes. And you can see that we will be connected to this machine. You can see here we have connected to this machine. So this green you can see 130 172.31.16.21 is nothing but the private IP of my machine. You can see here 172.31.16.21. This is the same. So from the command prompt of my laptop, through the SSH, that is the secure shell protocol, I am able to connect to a virtual machine which is present in North Virginia region, and I'm going to access it. Now I can install Nginx, I can install any web application on it, I can create directory on it. Okay, I can create anything. Okay, mkdir WAN. ls. Okay, you can see the directory has been created. I can do anything, right? I can create a file, I can install a web application, I can install a Docker application, and anything, right? This is the beauty of the cloud computing. This is a very small example. Please, again, I am telling, please don't get confused or hyper that what is the keep here, what is the instance type, and other things. Only you have to understand that from your computer, using a single command of SSH, using the public IP, okay, using the public IP, you can't give the private IP, okay. Private is a closed IP which can be used within that small network. Public IP means it can be accessed from anywhere around the world. Okay, just giving the public IP, you can access this public instance, public virtual instance. So, isn't it beautiful? Otherwise, we have to take a space, we have to install server, we have to put one CPU, we have to put 1 GB memory, then we have to put a personal a technician to correct it, then we have to use electricity power. How much cost? And when it is done, your server you have used, because it is pay as you rent, you just, okay, you just click on it, go to the instance state, and you please terminate it. Okay, why terminating is important? Because the charge which for the time for which you are using the instance, you are getting charged. You can see now the state is shutting down. It is very clear, right? So how you don't think it's very simple, and it is very convenient for anyone to use. Now let's wrap this session with a quick pointer. I request you guys, if you like the class, or you want to continue for this course, which is a combination of AWS System Ops Administrator course plus a part of DevOps, okay, you please come up tomorrow with this dashboard ready. I want you guys to create your own instance, and to connect to it, and we will learn 5 different ways to connect to the instance, and via it's through your laptop, via it is through git bash or the WSL which is present in your laptop, and I will teach you how to make use of that WSL or git bash, whether through the SSH clients, whether it is Movaxterm or Putty. Okay, you should know how to use them. They are open source. And some plugins I want, actually I want you guys to download Virtual Studio. It's very easy. If there is any issue, it will take just 5 minutes, we can do in the class. I want you to install git SCM. I want you to install AWS CLI, Terraform installation, and GitHub code spaces. It is just like a virtual machine only. So don't get confused now. Actually, these things are prerequisites for or for our laptop to have. But for now, I will take this one by one as we require. But the main important thing is, please do the console ready, your AWS console. Go for free tier account, and we can further do the hands-on on this, and we can understand the beauty of AWS cloud and its wonderful services. So I think we are ahead of time, and any questions by anyone, please?